Afternoon, everyone. Today we are going to see about language model LLM in deep learning. So first we are going to see about artificial intelligence. AI is a broad field that aims to simulate the human intelligence and behavior. Machine learning, deep learning, and generative AI are an umbrella of artificial intelligence. All these things require data for learning purpose. There are two types of AI, traditional AI and generative AI. In traditional AI, which is mainly used for analyzing the existing data and for prediction. In generative AI, we use large language model like LLM for generating the new content from the text to image, etc. So the evaluation, as of now, we see the evaluation. First, we call it as an AI, then machine learning, then deep learning. Now the generative AI has evolved. These are the scenario or the types. So first is an artificial intelligence. Machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning, and generative AI is, and then large language model is a subset of generative artificial intelligence, generative AI. In short, we will be calling it as generative AI. So let's learn how the generative AI works. The human initially learns from the surroundings and then surroundings from the teachers and then parents, and they learn after a few years. If we show the image and we will ask them to find where is the soup, they will identify it. This is the soup. Based on that, after keep on training and then learning, they will have a knowledge and their way knowledge after several years based on their experience as well as knowledge. If they can able to create their own soup of themselves, then it is called as a generative AI. So machine learning, as we have already discussed, machine learning is a subset of uh, artificial intelligence. See how they are predicting this. So first, for the machine learning, we need to give the large input data sets of images, what it is soup, what are the different types of soups that are available, or the text data, Excel sheets, or anything we can give as an input to the machine learning. And then and it uses some models to classification. For that, we need to give the pre-processing the data. What is pre-processing? We are going to normalize the data in some manner, that is as a numerical manner. Then we need to find the features. We have to explicitly find the features. What are the features? For example, color of the soup, picture of the soups, what are the ingredients used for making that soup. All these features we have to give. Based on that, it will be giving the classification whether it is a tomato soup or any other soups. This is how the machine learns for the prediction or making the decision about the soup classifications. This is a general block diagram. First, we are going to give you the image of soup photos. Minimum hundreds of soup images we need to give. Then we need to go for the image pre-processing, compare. We do resizing, normalization, noise removal, color corrections, and then we go for the feature extraction from that image. After that, we need to give the which are the best features so that it can able to classify it. For that, we have a classification algorithm like PCA, LDAs, etc. Then we need to give for the ML classifier algorithm to find whether it is a Zomato soup or a mushroom soup or veg soup, etc. So some of the use cases for the machine learning or recommendation system, fraud detection, yield optimization, etc. Where these are the some of the application where we can use machine learning. The machine learning algorithm uh, able to classify or predict the pattern without any neural network based upon our training data sets. We need to give a data set and we have the pre-processor and we have to give the features for their classifications. So here there is no neural network is involved for the machine learning. In later case, that is deep learning. It uses a neural network which is inspired from the human brain for learning themselves. What are the features that are required for the classification? Whereas in machine learning, we need to give the features for the classification. In deep learning, we give a large, enormous amount of input data sets. Based on that, it does pre-processing steps and it uses of algorithms for pre-processing. Then it goes for the deep learning models, and here each and every neurons will learn the features, for example, texture, size, color, and the quantity, what are the ingredients, all these things are being learned based on that learning neurons. Then it will be classifying their then it will be classifying whether it is a tomato soup or that or mushroom soup or anything. So here, see the block diagrams. The first one is an image for a soup. Then we go for image pre-processing, then feature extraction and classifications. Okay. For this feature extraction, we need to go for the deep learning algorithms like CN and convolution neural network, which plays a major role for the image classifications. These are the some of the use cases for image recognition, natural language processing, autonomous vehicles, and chatbots, customers. For example, ChatGPT. Nowadays, we are using the ChatGPT. These ChatGPTs are created using the deep learning algorithms. Next, generative AI. It is a subset of deep learning algorithm. There are two types of generative AI. First one is the text generation. Next one is an image and audio generation. For example, here we are going to give ChatGPT is the best example for the text generation, or as Google Bard is an example. Next, for the image or audio generation, if we are able to create our own PPT using Gemini AI like that. These are the example for generative AI. So LLM is mainly used for the text generation, and diffusion models are used for creating images and auto generations, etc. So now we are going to see about large language model. Large language model is an advanced AI system built on deep learning techniques for processing, understanding, and generating human-like. For generating human-like images. So the LLM working model, or the phases of the LLM are: first we need to give an input, then embedding positions and positional encoding, then deep encoder blocks and decoder blocks and output. For this LL, the transformer architecture is mainly used. So here the input embedding convert the text into the numerical vectors. All the text given inputs are converted into the numerical vectors. Then the positional encoding, adding the sequence number, because the machine does not know which word or the which word comes after the each sentence. Then we go for the multi-head self-attention model. This mainly the self-attention model used in LLMs are mainly used for finding the relationship between the each words. What is the correlation? For example, if if we say I am coming, who we have to specify who is this I, who is this I? So in the sentence or the paragraph, we may give that the Nitya Kalyani is a person who is delivering this lecture. So here I say, if I am coming, then I here automatically depicts that Nitya Kalyani. So it automatically finds a relationship between the two words. Then feed forward for capturing the complex patterns. Then the decoder, which is used for converting from the one language to the another language. So LLMs are mainly used as a translators. All the translator architectures for converting English to Tamil, Tamil to English, all these algorithms, or all these applications uses the LLM as a model or approach for converting their what type of text into the another type of text. So this is the general architecture of the transformation model. First, we need to give input, then input embedding, then positional embedding. After that positional embedding, we are going to get a vector. That vector will be given to the multi-head attention model. This attention model is very, very helpful for finding the relationship between the current word and the previous word in the encoder. This is the first left-hand side is the encoder block, and the right-hand side is the decoder block. All this vector will be given to the decoder block, where the decoder will take and each and every vector, and it will convert into a output. So let us see an example. So the cat sat on the mat. So we are going to get the desired output as a பூனை பாயின் மீது அமர்ந்தது. So first we need to go for a tokenization. So all the word the cat sat on the mat will be tokenized. All this will be converted into sub tokens. Each and every word will be splitted. For example, here we have 7 tokens. All these tokens are given as an input to your vocabulary. So next, convert each token into number. What is vocabulary? Vocabulary indexing is nothing but finding the words in the dictionary for in order to find the unique ID. For example, in that dictionary, for the ID may be 1523 on 1023. So mat 8891. Similarly, we have an each and every word in this world are having a vocabulary and their unique ID for all these are stored. For example, in ChatGPT, we do have 798. Now, all these sentences are sorry, all these tokens are converted to the unique ID because we do have a large number of words. All these words have a unique ID and it is represented as a dictionary. All these words will be taken and it is represented in a vectors. So vectors, what does mean by vectors? Vector is nothing but a collection of numbers. Okay. So we are going to convert this ID into embedding vectors. Or see here, for LLM, the BERT model or GPT model uses a 768 dimension. What is this dimension? The dimension is nothing but the features. So we are going to embedding all these features. For example, the cat. For example, 768 words. We will be features are there. So we are going to correlate that word and with each other, finding the values for that. For example, we have 7 tokens into 768 dimensions. So we are our current matrix will be 7 into 768 matrices. Next, we will do a positional embedding. As I told that a position, why, what is this position means, which word comes first. So D comes first. So we are embedding as a P0. Next, cat P1, P2, P3. This is the positional embedding. What is E? What is E? E is nothing but the vector, what we have find in the previous model embedding. In this embedding techniques, that is 7 into 768 models. All the 7 into 678 vectors will be added with that current positional vectors for adding positions. Next, we are going to get the final output as a matrix 7 into 768 matrices by the encoder with the self-attention model, which will be finding the relationship that the value is nothing but the relationship. That is nothing but correlation. What we will use it as correlation. So how much it is correlated based on that the values are given, then that input value here we are seeing, right? These things will be fed into our decoder model. This decoder model will take all this value and it sees similar to that of encoder. It takes the each and every value along with the positional embedding and it verify uh, with their vocabulary identity. For example, if it is we are going to convert it into Tamil, it will check into the vocabulary ID with the Tamil. In encoder uses a self-attention model in order to focus on the finding the relationship. So this is the formula that it uses to calculate how the values are similar. So this is a value for the self-attention score, the 0.1, the cat 1.0, sat 0.8. Like this, we will be getting based on that embedding scores. So based on the self-attention code. So next, all these values will be fed into our decoder model. We have a target token embedding. That is, we have output of the encoder technique. Then we have a self-masked attention. What is masked self-attention? In encoder, we use a self-attention model. Here we use masked self-attention, which means decoder need not know about the previous word what it is converted or what it is used. or what the word it is framed. The decoder need not know the previous word, or you need not need to find relationships. Next one, the cross attentions. What is that? What is meant by cross attention? For example, we are going to map this English sentence into Tamil, so we are going to cross verify with the vocabularies. Next, softmax. Next one, auto aggressive loop. These are the steps used in the in decoder. All these positional vectors are taken one by one, and it is converted into Tamil sentence. Ponai, Payin, Medu, Amandadu. So we have initially we will have a start token, and the end we will have a end token. So master self attention, Punai. Once we get an output as a Punai, next word Punai Payin Medu, Amandadu. Punai Payin Medu. So the Payin need not correlated with your uh, pie, pine, பூனை. Next one, cross attention. In this cross attention, each and every word is looked into our vocabulary for finding the words. For example, the பூனை, the cat, pine, mat, medu, on, among the sad. Next, feed forward network. It's just like the encoder. It uses an activation function called as a relu or glue. Next, the linear transformation model. Then we will be getting the soft max, which is nothing but a normalization. So we are going to get our output, that is the Tamil word பூனை பாயின் மீது அமர்ந்தது. This is how our word the cat sat on the mat is converted into Tamil, that is LLM end-to-end pipeline. So first we have to take the text and we have to first tokenization, then we need to embed technique, and then encoder and decoder, self attention mod output. So this is how the entire systems converts our things from this from English to Tamil translations. So the LLMs are mainly used for generating the text, whereas a generative AI can able to create text, audio as well as video. But LLM is a subset of generative AI for creating the only the text values. Okay. This is how they are converted. The main purpose and the summary. What is the use of tokenization? That's tokenization breaks the word into unit. Embedding means we are going to convert the tokens into vector. Positional embedding means we are going to add sequence number. Self attention, finding the relationship between the two words. Encoder output, meaning representation. The decoder generates the translation model. And the encoder and decoder attention, that is cross attention. Here it maps the English words into Tamil, and softmax choose the next keyword, next words. So advantages of using or the challenges that are faced by the large language models, or large language model can be used extensively for creating the text, and it is more flexible and performance is more and accuracy is very high. Only all these LLM models learns the input from their given data sets. All the data sets, we have to give billions of data for identifying the each words. And we see once we see the new word, it immediately adds to the vocabulary, and the vocabulary ID will be given to each word. Then ease of training and efficiency. The challenges that is posed by the LLM is development cost, operational cost, and need bias. If you are giving the same input, for example, the soups, all the soup contains only these types of features. We need water, and this all the soups will contain only red color. Then the LLM model learning is itself that if it is a red color, then it is soup. It will not give that whether it is a uh, watermelon or any other soup or pomegranate soup. Instead, sorry, a pomegranate juice. Instead, it will always give it as a soup. Soup. Ethical concern is very important because it uses a large data set from various places. All it we need to give all the data which is true. Next, explainability and hallucination. These are the some of the challenges that are faced by the LLM model. So main difference between the generative AI and machine learning and deep learning, deep generative AI focuses only on autonomous for creating the images and text automatically. Here we are going to create the text or images or audio files. In machine learning, it is mainly used for predicting the patterns. Whereas in deep learning, it is also used for predicting the pattern or making the decisions. Here we don't need to give the features, but the deep learning itself takes the features and then it will give our output. Learning takes place number of times because we have input layer, output layer, and hidden layers. So a core function generates a new content based on learning patterns, analyze the data to make prediction and decision. In deep learning, complex patterns are also identified with accurate key algorithms that are used for generative algorithms, GAN and WAN, and diffusion models and machine learning algorithm, decision trees, support vector, random forest, and deep learning algorithms. We have used the convolution neural network and or and recurrent neural network and transformer. In LLM, we don't have the word at what it comes and the which word comes at what time. So are the sequence numbers. So that's why we are going for a positional embedding. Whereas in a recurrent neural network, it is mainly based on the time series, text generations and the etc. Thank you.